Hello and welcome to R&D Mathematics. Today we look at a problem. Now suppose you are a teacher of 10 students. Now you have 10 students and you need to make a group of 4 students. So you need to make a group of, you need to choose a group of 4 students. So at random, right? Now you think of this problem. Now let's have a look at this problem. So the number of ways you can do this is actually 10 choose 4, right? But now let's say there is a student, there is one student, let's say his name is John. Now this guy is a troublemaker. So this guy is a troublemaker. Now you are thinking the number of ways that you can do this with John and without John. So if we go with John, let's call it the easy group. Easy group, and this is the difficult group. So easy group and difficult group. Now, how many ways are there you can do this with John? Now, if you think carefully, since you already have John, you only have to choose 3 students, right? Out of 9, not 10. I think that makes sense. Now, the next case, without John. So in this case, we still have to choose 4. But we only have 9 to choose from because without John, right? Now these two together will cover all the possibilities. Because of that, we must have 9 choose 3 plus 9 choose 4 to be this number, right? 10 choose 4. Now this result, actually nothing, it's nothing magical about these numbers 10 and 4. It works in general. This argument works in general, and if we generalize it, n choose k plus n choose k minus 1. Let me put it the other way around. So n choose k minus 1 plus n choose k equals n plus 1 choose k, right? Now this example is just a specific case of n equals 9 and k equals 4, right? Now that is the physical, what's happening in this equation is clear when you look at this example. Okay, now let's try to prove this. This is known as actually Pascal's rule or Pascal's identity. Now let's prove this using algebra. Even though we can prove it using algebra easily, that example I gave you is actually pretty nice to understand that, to see what's actually going on. Now, if we convert this into factorial notation, this is n factorial k and n minus k. That is the definition. And here we have factorial n over k minus 1 and then n minus, don't forget the parentheses, k minus 1. So this is left hand side. Let's start with left hand side and simplify it. Now we have to be a little bit careful here when dealing with factorial. See, I can see this term, that's common in numerator, that's good. And in the denominator, factorial k, I see factorial k here, and I see factorial k minus 1 here. Now factorial k is k times factorial k minus 1, right? Now I'm going to use that to modify. See, what if I multiply by k minus 1, sorry, not k minus 1, by k, both numerator and denominator in my second term. Then I will get factorial k, right? Now here minus k plus 1. And over here factorial n k. Now next two terms, this one and this one, we can do the same thing. N minus k plus 1. That is factorial, sorry, n minus k into no, n minus k plus 1 into factorial n minus k, right? So I'm going to do the same trick over here. So multiplying by n minus k plus 1, both numerator and denominator. Then what will happen is this here, sorry, here I have factorial. So this term now is actually factorial n minus k plus 1, right? So I have it over here, and this term is factorial k. So I have it over here. So now I created the common denominator. Now all I need to look at my numerator. In my numerator, factorial n is common. I can take that out. So n minus k plus 1 plus k, which is nice. Why k will be cancelling. So I have here factorial n times n plus 1, right? Divide by factorial k times n minus k plus 1. Let me rewrite it, n plus 1 minus k. So I just rearrange the last two terms, factorial. Now what is this? This one right here is factorial n plus 1 divide by factorial k n plus 1 minus k. Now this one is nothing but this guy over here, and that is right hand side, and we are done. Thank you.